Hi, my name is Mohamad Fikri bin Mohamad Osman. In this video, I'm going to present subject DCC6223 reinforced concrete design. My matrix number is 05DKA18F1108 and I'm from DKA 5 section 3. In this video, there are 5 main topics that I'm going to cover, which is the first one is definition. The second one is why reinforced concrete design is important. The third one is example of existing building in Kuching. And the fourth one is concept of reinforced concrete design. And the last one is fundamental step in slab design. Moving on to the next slide, which is definition of reinforced concrete design. So basically, reinforced concrete design is the common terms given to a concrete member or slab that contains steel reinforcement, usually in the form of steel bars, to increase the strength of the structure. The material that results from the combination of concrete and reinforcing bars is called reinforced concrete, RC. During the construction, the reinforcement steel is placed in the formwork first, either in the form of prefabricated steel cage or steel rebars that are fastened together and wired in situ. Then, concrete is poured in the formwork and vibrated using adequate devices so as to guarantee a high level of collaboration between the two materials. Next one, why reinforced concrete design is important. One of the main disadvantages of concrete, it is very low tensile strength that is practically exceeded at low levels of load. This results in cracking of the concrete surfaces that in turn leads to aesthetical problems such as large deflection of beam or slab for the service ability limit state as well as structural integrity problem at the ultimate limit state. On the other hand, reinforcing steel has rather high tensile strength and a symmetrical material constitutive low under tension and compression. However, a rebar alone that is subjected to a compression fails prematurely due to buckling. For this reason, use of reinforcement in reinforced concrete section leads to effective structural behavior as reinforcing steel works effectively under tension and concrete works effectively under compression and confines the compression reinforcement. This is the example of existing building in Kuching. For your information, this is the new building at Sarawak General Hospital. Moving on to the next slide, which is concept of reinforced concrete design. For our syllabus, which is diploma student, there are 3 fundamental things that students need to understand and can interpret into the designing of reinforced concrete. The 3 fundamental things is the design of slabs, design of beams, and design of columns. In the end of the learning process, student, which is us, should know and understand on how to design the 3 common things. Students should know the structure of reinforced concrete, code of practice, and basic design requirements. On the other hand, students should know the terms such as the design working life, limit state, design situations, and exposure situation, and lastly, the action. Moving on to the last subtopic, which is fundamental steps in slab design. Slab are horizontal plate elements forming floor and roof in buildings and normally carry lateral actions. Slab may not be of solid uniform thickness or with ribs running in 1 or two directions. There are 6 types of slab, which are one-way slab, two-way slab, rib slab, wafer slab, flat slab, and lastly flat slab with drop panel. On the other hand, there are 4 types of designing slab, which are design of simply supported one-way slab, design of continuous one-way slab, design of simply supported two-way slab, and lastly design of restrained two-way slab. In designing of slab, there are 6 steps we need to carry out, which is the first one is specification of and slab thickness. The second one is durability, fire and burn requirements. The third one is action and analysis. The fourth one is main reinforcement. The fifth one is table of bars, and lastly detailing of the slab. So moving on to the first step, which is specification and slab thickness. According to book Reinforced Concrete Design, UTM edition November 2015, you should refer 1.5 for permanent action, which is the GK, table 1.6 for variable action QK, table 1.3 for design life, table 1.4 for exposure classes, table 5.5 for fire resistant, for checking and determine the specification of the slab. And for the slab thickness, I choose H equal to Lx over 35 because it is recent slab. So for the other 3 formula, which is for the one-way slab simply supported, the formula for H is Lx over 26. For continuous one-way slab, H equal to Lx over 30. And lastly, for simply supported two-way slab is H equal to Lx over 25. And then moving on to the second step, which is durability, fire and burn requirements. You should refer table 5.5 for Simindur, which is the durability regard. And then you follow the assumption of diameter of bar for checking the Simin B. And then for table 5, refer table 5.4 for minimum required exist distance referring the fire resistance. And then you should checking your C min and also the C deviant for determine the nominal cover, which is C norm. And then moving on to the third step, which is finding the action and analysis. For finding action and analysis, the step is find the value of design action, which is the formula is 1.35 GK plus 1.5 QK. And then you must find the value of moment negative and positive at short span, as well as finding the moment negative and positive for the long span. Moving on to the fourth step, which is main reinforcement. So main reinforcement, you should find the value of effective depth first, and then moving to the minimum and maximum reinforcement area. And then you should find the value of short span of AS using the formula, which is K and then Z. Then give AS required at mid span and support. For the long span as well, you should find the value of AS using the formula, then give AS required at the mid span and long and support. And then moving on to the fifth step, which is table of bars. You need to find the value of center to center of bar by referring the table of reinforcing steel, and then moving to the length of the bar at the middle support short span, then the length of middle and support long span by using the formula, which is 0.2 multiplied by L and then multiply by 2. And lastly, you should find the value of number of bar at the middle and support short middle and support short span, and then as well as middle and support long span. And lastly, you should sketch or draw a detailing of the slab, such as reinforcement bar, graph of moment, and the middle support at both span, which is short and long span, and lastly the number of bar at both span. So thank you for watching my video.